Okay, this is our hydrogen setup. Here's our fuel cell. Here's our water reservoir and bubbler system. Here's one of our safety features. Just in case it blows up, there's a plastic membrane right there that will blow instead of the whole project blowing up. Here's our pump with the cooling system to cool the electrolyte. And here's so that we can measure amperage and voltage. Okay, so right here we have a device that's going to get the amperage and basically measure on this meter right here in millivolts instead of amps. So the reading we get on this right here is going to be how much amperage we got. Okay, so here's the cell. There's 72 plates. Excuse me, there's 70 plates. Right now we have it in this configuration, which is neutral, positive, 4 neutrals, negative, 4 neutrals, positive, and so on. The pump right here is run off of this battery, and we're getting ready to start right now. Here's our measuring device to measure how much production we have. That's a work in progress. Right here we have a bucket to display that we are making HHO. We're going to get it running now. Okay. We're going to get ready to run at 12 volts at approximately 60 amps. We got 62 amps. And we're not getting the full 12 volts. It's at 11.3 volts because there is a load on the battery. So right here we can observe that this is HHO. Right now we're approximately getting about 3 liters, and once again at approximately 12 volts at 62 amps. Okay, so here we're producing the HHO. We submerged a half-liter bottle into the bucket, and we have our HHO going right here. And we have a stopwatch that's going to measure exactly how much time it takes to fill up this liter bottle, the half-liter bottle. We're going to do a little bit of math and figure out exactly how many liters per minute we're going to get. You want the camera? Okay, so you just press OK.
Yeah.
Okay, yo, you press it. Okay, so wait, stop. Ready? Go. Time. 10 seconds. So with 10 seconds, I don't know if you can see it well, 10.55, we're approximately getting 3 liters per minute. And now we're going to go into 28 volts. So we tried running the cell on 28 volts, but some of the connections started smoking at the top. We were getting 200 amps, and we had a lot of production. So we tried eliminating half of the cell, just working on this side, but still connections started smoking up. So basically what we're trying to do is just stay to 12 volts at approximately 50 amps. So that goes to show that this is very much a work in progress. And the experimentation will continue on to next year when we have time. So basically we're going to go and explain a little bit about the unit itself. This cell is 70 plates like I said before. It's a neutral, positive, neutral, negative configuration. 4 neutrals in between the cathode and anode. So basically this is where the electrolyte is held. The electrolyte for this unit is distilled water with 1 teaspoon of potassium hydroxide per gallon. So right here the electrolyte, it's stored. We have two towers basically, so the volume of electrolytes greater. We have a bubbler in the middle. Basically it's a safe device. It's like a check valve, so that if there is a spark through here, it stops it, and when it does blow up, the little plastic piece right here blows off, everything's safe and okay. So basically there's a valve up there so we can add the electrolyte very easily. We mix it in the gallon back there, and then we just add it to the top. Right here is a radiator, basically used for computer water cooling, and basically it's a fan, radiator in between, so it cools the electrolytes so that we can still put more power to the cell. Here's our pump. So basically the water's taken from here, went through the pump. We have a valve right there, so just in case we want to run it without it, because it should run without it, gets pumped through here, comes out through the end. Right here there's a T, and then it goes into both sides, this side and this side. Water gets put all the way through, comes out the end and back into it. Inside there's a tube that goes all the way to the bottom, so the HHO rises up and the water stays at the bottom. So HHO goes up, down this tube, into the bubbler. There's water in the bubbler, bubbles up, that's why it's called a bubbler. And HHO just goes through here to this T. Right here is our measuring device, which we're still working on. And it comes out a valve into our bucket, which we're currently using as a measuring device. So right now we have little tubes right here so you can check exactly how much water is in it. So right now it's like yay high, and the same thing on the bubbler. Check exactly how much water is inside each. And these are connections. We added 7 on each side, so there's a total of 14 for each bar. Basically, it's hooked up like this. This is I think it's 2-gauge wire running to each piece of metal, and then basically the piece of metal transfers the electricity onto each plate. So the reason why we have such a thick gauge wire is so that we don't have problems with burning up the wires. This is what we're using this battery we're using to run all the accessories like the radiator and pump, and that's about it. So then we have our 2 meters, check our amperage and voltage, and this is our unit. This is all this is done at Baker Aviation in Mr. Carter's class, and we're basically sponsored by TSA, Inventing the Skills USA.